In this video, we're going to review what we've learned so far about confidence intervals. So we're going to start out with this exercise. The drug Lipitor is meant to lower cholesterol levels. In a clinical trial of 875 randomly selected patients who received 12 milligram doses of Lipitor daily, 53 reported a headache as a side effect. So if we're going to go through our given information here, we were told how many people were in our trial. So we have our sample size. We were also told how many of those people, of my 875, reported a headache as a side effect. So we have an X, a number for a particular success, which in this case is having a headache as a side effect. They also gave us the amount of the dosage, but that doesn't particularly matter to us. So the first question here says, verify that the requirements for constructing a confidence interval are satisfied. Now, when we're constructing a confidence interval for a proportion, we need 4 things to be true, and they were listed on the previous page, and I said these are very important. So the first of our requirements, we need each of these people or each of the trials to be independent of one another. So is there any reason that one randomly selected patient would influence the next randomly selected patient having a headache as a side effect? And since we don't have any reason to think that there's some sort of relationship between these patients, we have our independence. Number 2 was that we needed, if we were taking a random sample, for it to be a simple random sample. None of the kind of fancier sampling techniques that we talked about in the beginning of this course. No cluster, no stratified. So here, the only thing we see is randomly selected, nothing to indicate that it was done as a cluster or a stratified or systematic. So we'll assume that this is also good to go. Steps 3 and 4 are usually the 2 where we might actually have to do a little bit of math or do something to check, as opposed to 1 and 2. So step 3, or requirement number 3, was that my N is less than or equal to, is no more than 10% of the population size. This was our need, so that if we were doing sampling without replacement, that we are not going to have any issues with needing to think about how our probabilities have changed. It's small enough that we can kind of ignore that. So in this case, we know our N is 875. And the question is this less than 10% of the overall population of Lipitor users? I probably should have had enough here. And this is one of those things where without the actual number of Lipitor users, we kind of get to just check this off like we did the first 2 requirements. There's nothing here to tell me that there's less than 8,750 people using Lipitor. And in fact, it's probably higher than that, so we're okay. But this is something where if this is going to be violated, we usually will be given or we'll know the population size. So I gave an example of this actually in one of my classes on Thursday, and that was if I was going to do a sample of my own statistics students. Well, there's only 150 total of you guys this semester, so if I took a sample of 30 of you, then I'm going to get into trouble because I'm over that 10% or 15 students. The last one is that our rule of thumb needs to hold. We need to make sure that our successes and failures are greater than or equal to 10. Now, when we're dealing with a confidence interval, when we're dealing with trying to make some inference about real P, real Q, we can't use the traditional rule of thumb. We have to modify it to use our P hat and our Q hat. So in this case, our observed number of failures and successes versus our expected number of failures and successes. In order to do this, we do need to figure out what our P hat is. So we'd probably go up here and say, okay, P hat is X over N, which is 53 over our 875. Oops, I need you to be on. Looks like we have 0.0606. It is important you keep some decimal places here, especially when there's all these interim calculations that happen later, so you want to make sure you have at least 4. So if we were to do this calculation here, we go, okay, so 875 times that P hat we just found. Oops, that doesn't look good. 0.0606. We could also do Rn times our Q hat, which is just 1 minus that. So you could type that in your calculator and figure out what it is. Or like me, you've had a ton of practice. You don't need to. So you go, okay, let me see if we have our rule of thumb. 875 times 0.0606. And hopefully those of you a little more math savvy already realized that this was really silly. All I did was take x over n and then multiply it by n. So in theory, I just got x out, but kind of uglier. So it really, truly, I could have just looked at this is just always going to be your x. So our x, and then if 53 of these 875 had a headache, that means that 822 of them did not have a headache. Both of these numbers are greater than or equal to 10, so indeed we have our rule of thumb. We do have a large enough sample size that we can start to see that approximate normality. So since all of these things are true, this is basically confirming that our p-hats, our sample proportions, would follow an approximate normal like we saw in 6.1. And if that's the case, then we can go ahead and construct a confidence interval which relies on our normal distribution. And that's exactly where we're going next. It says construct a 90% confidence interval for a proportion. Okay, well, if you wanted to use the formula, you're going to the formula sheet and you are grabbing confidence interval for a proportion. It's right there. Remember, this is going to start with our p-hat, our point estimate, and then we're going to add or subtract our margin of error, which involves our critical value, times our standard error. So that's what the formula folks are doing. I will go ahead and finish it this way. If you want, you can just fast forward, and I'll go ahead and when I pull up the calculator, I'll do it in the calculator version. So to do it with the formula, we're going to say, okay, this was 0.0606 plus or minus. This z star, remember the new table I gave you guys? I should go grab that. No! All right. I'll pause this so I can grab my plug and also see if I can find the table. All right, so I'm back and I found my t table. So just to remind ourselves here, we were looking for a z star, which is our critical value, and we knew we had a 90% confidence interval. Now, this is a table I will be giving you on the test, a t-table, and the very last part of our t-table has all of our confidence levels and our z-stars for them. So if we wanted to do a 90% confidence interval like this particular problem, we can see the corresponding z-star is directly above it. So that's what we're going to be using, 1.645. So okay, oops, that's not what I want. I want to go here, close that, discard. All right, 1.645 is what we just found. And then our standard error is our estimate of the standard deviation using our p-hat. Since we happen to actually check to make sure our requirements are verified, we know our q-hat is 0.9394. Remember, this q-hat is just 1 minus our p-hat. And this is all over our n of 875. So if you're doing this by hand, here's where I'm going to screw up all those people who skip to try to do the calculator shortcut. I recommend calculating your margin of error first. So for your margin of error, I would come to my calculator. I still want you to be big. I just don't want you to be right there. Whatever, it'll work. I do this, 1.645 times our square root. I don't even need that time symbol. 0.0606, 0.9394, all divided by 875. So I like to try to do this all at once. I find that most of the errors students make is if they try to do these things in smaller steps. There's all sorts of rounding errors and then errors just in general where they forget to use the square root or they forget to multiply by that critical value. Lots of little mistakes. So if we do it all at once, we now get that our thing is 0.0606 plus or minus our margin of error was 0.0133. 0.0133. So if we actually add and subtract this, we'll do the subtraction first. 0.0606 minus, I could have used the answer button, but I want to be able to bring this back. 0.0473. And then I'm just going to do a second and enter to bring that back. And then I'll do plus, which is 0.0739. Now, if you have the little calculator, you can actually just go back and highlight the thing that you just typed in, and it'll pop it right back in the screen, and then you can add it. So you don't even need to do the second enter. It's easier on the little calculator. So if you want to know how to do that, just ask me during class. Now, remember, those people with the bigger calculator, you actually should have just used the calculator shortcut here. So we need to go into the stat submenu. We're going to go over tests. Past the one prop z test. Remember, we're not doing tests yet. Oops. All the way down to one prop z interval. We're doing a z interval for a single proportion. And then you're just going to enter all of our information. We have 53 successes, or people with headaches, out of our 875. And we want to do a 90% confidence interval, which is 0.9. And if we calculate it, we get out the exact same values. Actually, it looks like we have a tiny bit of rounding difference on this final 10,000th place of our upper bound. But very similar, and like I said, it won't make a difference on the test. I will do it both ways. So if you did this for your homework, the only thing I would ask is that as your homework, you write something like one prop, z interval, x equals, n equals, c level equals. So you've basically told me what you entered in your calculator as your work, because you can see the people who have to use the formula are going to show me a ton of work, and you're not doing quite as much. Our last step, the last thing we need to be able to do with our confidence intervals, is to interpret them. So in order to interpret our confidence interval, that's our beautiful sentence that we learned last class. We're going to say we are 90% confident. And then this is where the actual question from above is going to be really helpful, because we want to talk about how that real P is inside the interval we just caught, right? That we're pretty sure we have it. And that's exactly what the wording here is going to give you. So we're going to say we're 90% confident that the population, and I could write true population like we had in our little sentence last time, but like I said, you can always just use this. Proportion of Lipitor users who will report a headache as a side effect. And here again, you have some options. You could say something like is within our interval or whatever. I like to say is between 0.0473 and 0.0739. So that's it. Big important things, just to reiterate. We definitely want to be using this word confident, because we're not talking about a probability when we're talking about confidence intervals. Probabilities are about like random things, and our P is not random. It is a true set value. We just don't know what it is. So you have to use this word confident. Another thing that you need to have in here, you need to have something to indicate that this is the real deal proportion, that it is not just the sample proportion. This is the population proportion, the one that we want to know about, but we can't actually find out about. We can just estimate. You do want to have some word with proportion, so we know we're talking about proportions. Because later on, in one of my classes on Thursday, a lot of people kept saying the number of people who have a number of people, and I'm like, we're not talking about a number here, because we're talking about proportions. So those are the sort of three big pieces.